A spaceplane is a vehicle that can fly and glide like an aircraft in Earth's atmosphere and maneuver like a spacecraft in outer space. To do so, spaceplanes must incorporate features of both aircraft and spacecraft. Orbital spaceplanes tend to be more similar to conventional spacecraft, while suborbital spaceplanes tend to be more similar to fixed-wing aircraft. All spaceplanes to date have been rocket-powered but then landed as unpowered gliders. 3 types of spaceplanes have successfully launched to orbit, re-entered Earth's atmosphere, and landed: the Space Shuttle, Buran, and the X-37. Another, Dream Chaser, is under development. As of 2019, all past, current, and planned orbital vehicles launch vertically on a separate rocket. Orbital spaceflight takes place at high velocities, with orbital kinetic energies typically at least 50 times greater than suborbital trajectories. Consequently, heavy heat shielding is required during re-entry as this kinetic energy is shed in the form of heat. Many more spaceplanes have been proposed, but none have reached flight status. At least 2 suborbital rocket-powered aircraft have been launched horizontally into suborbital spaceflight from an airborne carrier aircraft before rocketing beyond the Kármán line. The X-15 and Spaceship One spaceplanes must operate in space, like traditional spacecraft, but also must be capable of atmospheric flight, like an aircraft. These requirements drive up the complexity, risk, dry mass, and cost of spaceplane designs. The following sections will draw heavily on the US Space Shuttle as the biggest, deadliest, most complex, most expensive, most flown, and only crewed orbital spaceplane. But other designs have been successfully flown. The flight trajectory required to reach orbit results in significant aerodynamic loads, vibrations, and accelerations, all of which have to be withstood by the vehicle structure. If the launch vehicle suffers a catastrophic malfunction, a conventional capsule spacecraft is propelled to safety by a launch escape system. The Space Shuttle was far too big and heavy for this approach to be viable, resulting in a number of abort modes that may or may not have been survivable. In any case, the Challenger disaster demonstrated that the Space Shuttle lacked survivability on ascent. Once on orbit, a spaceplane must be supplied with power by solar panels and batteries or fuel cells. Maneuvered in space, kept in thermal equilibrium, oriented, and communicated with on-orbit thermal and radiological environments impose additional stresses. This is in addition to accomplishing the task the spaceplane was launched to complete, such as satellite deployment or science experiments. The Space Shuttle used dedicated engines to accomplish orbital maneuvers. These engines used toxic hypergolic propellants that required special handling precautions. Various gases, including helium for pressurization and nitrogen for life support, were stored under high pressure in composite overwrapped pressure vessels. Orbital spacecraft re-entering the Earth's atmosphere must shed significant velocity, resulting in extreme heating. For example, the Space Shuttle thermal protection system protects the orbiter's anterior structure from surface temperatures that reach as high as 1650 degrees Celsius, well above the melting point of steel. Suborbital spaceplanes fly lower energy trajectories that do not put as much stress on the spacecraft thermal protection system. The Space Shuttle Columbia disaster was the direct result of a TPS failure. Aerodynamic control surfaces must be actuated. Landing gear must be included at the cost of additional mass. An air-breathing orbital spaceplane would have to fly what is known as a depressed trajectory, which places the vehicle in the high-altitude hypersonic flight regime of the atmosphere for an extended period of time. This environment induces high dynamic pressure, high temperature, and high heat flow loads, particularly upon the leading-edge surfaces of the spaceplane, requiring exterior surfaces to be constructed from advanced materials and/or use active cooling. The Space Shuttle was a partially reusable low-Earth orbital spacecraft system operated from 1981 to 2011 by the U.S. National Aeronautics and Space Administration in Florida. Operational missions launched numerous satellites, interplanetary probes, and the Hubble Space Telescope, conducted science experiments in orbit, participated in the Shuttle Mir program with Russia, and participated in construction and servicing of the International Space Station. The Space Shuttle fleet's total mission time was 1,322 days, 19 hours, 21 minutes and 23 seconds. Space Shuttle components include the orbiter vehicle containing liquid hydrogen and liquid oxygen. The Space Shuttle was launched vertically, like a conventional rocket, with the two SRBs operating in parallel with the orbiter's three main engines, which were fueled from the ET. The SRBs were jettisoned BEF.